So in the previous video, I introduced the upward compression. Let's have a closer look to this specific type of compression. We know that it is used to bring up the level of a quieter portion of the signal. By doing so, its ratio now is 1 to values that are less than 1. In this example, 1 to 0.5. If the signal is above the threshold, we don't care because we are into the unity gain. As you can see from the graphics, minus 3 dB for the input level, minus 3 dB as well for the output level. But if the signal is below the threshold, like in the following example, we have the input level at minus 9, it will be boosted by 1 dB so that the output is now minus 8 dB. If you're wondering why is the downward compressor the most commonly used, well, the answer is pretty simple. Thanks to downward compression, we can shape sounds because we are working with peaks, with those parts of the signal that are exceeding, so we can reshape them. By using an upward compressor, we can only boost sections with low volume, so we're not working on peaks. The next topic is Lookahead, also called pre-comp in some compressors. It is specific to digital compressors only because it will look ahead in the waveform and identify where the waveform will exceed the threshold. By applying a time offset, the compressor is not working considering what is going on during playback. In the image you see on screen, the yellow line is the playback position. So we are compressing during playback position, considering the peak that in 100 milliseconds will exceed the threshold. If you're dealing with super percussive sounds, adding some pre-comp might be the solution. Even if we set the attack time to 0 milliseconds, there is some tolerance. Your compressor might not be as precise as you set it. So by applying a time offset, we can predict when those peaks will happen, giving us the ability to open the compressor earlier so that when the peak will exceed the threshold, it will be instantly attenuated. Short attack times and very low frequencies don't get along very well. Let's take a sine tone at 50 Hz and let's find its time period, the time needed to complete a full cycle from peak to peak. To do so, we can use the formula T, which is time period, equal 1 divided by the frequency, resulting in 0.02 seconds. Our sine wave will take exactly 2 milliseconds to complete a full cycle. If we set an attack time that is less than 0.02 seconds, this will cause discontinuities because the wave has not yet completed a full cycle. This can be perceived as a distortion. So the suggestion I can give you is make sure not to use ultra-fast attack times or release times when you're working with extremely low frequencies. Now, in the context of a full song, these tiny distortions can be easily masked by the other instruments, but in any case, this is an aspect that you should consider. On the other hand, we can use this limitation as an artistic effect. A fundamental distinction between compression types is peaks versus RMS. So if our compressor is set in peak mode, it will consider every tiny amount of waveform exceeding the threshold. So our compressor will work with a very high resolution in time. If we set it in RMS mode, and by the way, RMS stands for root mean square, a value that represents the average power of an audio signal, the compressor will process the signal considering its average loudness, not its instantaneous loudness, something like the orange line on screen. We can use plugins like the Kotelnikov by Tokyo Labs to change between peak and RMS, and we can select all values in between, so we don't necessarily have to work with an RMS or peak compressor. We can select something in between, and this depends on the audio source you're working on.